For oil to do all of the work that's expected of it, it must have special properties. Its viscosity is crucial. Viscosity is a measure of how easily a liquid flows. Low viscosity liquid is thin and flows easily. High viscosity liquid is thick and flows slowly. Lubricating oil must be thin enough to circulate easily between moving parts, but not so thin that it will be forced out from between them. If it is forced out, parts will be left in direct contact and they'll be damaged. If it's too viscous, it moves too slowly to protect parts, especially in a cold engine. It was once normal practice for engines to need one grade of oil for summer and another for winter. Oils are graded or classified by the American Society of Automotive Engineers, or SAE. An engine oil with an SAE number of 50 has a higher viscosity or is thicker than an SAE 20 oil. Oils with low viscosity ratings, say SAE 5W, 10W and 20W, were tested at a low temperature, around -18 degrees Celsius, and were used for cold conditions. Oils with high viscosity ratings, say SAE 20, 30, 40 and 50, were tested at a high temperature, around 99 degrees Celsius, and were used for hotter conditions. Modern oils, however, are blends of oils which combine these properties. The oils are blended with additives called viscosity index improvers to form multigrade or multi-viscosity oils. They provide better lubrication over a wider range of climatic conditions than monograde oils. Oil is also classified by the American Petroleum Institute, or API, service classification. Oils for spark ignition engines carry a prefix S, and diesel or compression ignition engines use C. Some oils have additives that make them suitable for both. Manufacturers recommend which viscosity and API classification is ideal for a particular engine. Special chemicals called additives are added to the base oil by the oil companies. Different combinations of these additives allow the oil to do different jobs in an engine. Extreme pressure additives coat parts with a protective layer so that the oil resists being forced out under heavy load. Oxidation inhibitors stop very hot oil combining with oxygen in air to produce a sticky material like tar that clogs galleries. Corrosion inhibitors help stop acids forming that cause corrosion, especially of bearing surfaces. Anti-foaming agents reduce the effect of oil churning in the crankcase and minimize foaming. Detergents reduce carbon deposits on parts like piston rings and valves. Dispersants collect particles that can block the system, separate them from each other and keep them moving. Then they will be removed when the oil is changed.